네, 아니기에는 약간 아니기에 또 있어.
Hello. Yeah. during the welcome address, we just do give to the guest.
I request the dignitaries to felicitate the chief guest.
Yeah.
Before lighting of the lamp or after lighting? After lighting of the lamp. I'll start. Good morning and warm welcome to everyone. As fresh as the morning dew and as vibrant as the colors of rainbow, we gather today for an event that promises to be exciting. Myself, Sahana, on behalf of the organizing committee, we are pleased to announce the first joint international conference on advances in mechanical and aerospace engineering. The conference is jointly organized by Alliance University and University of Strathclyde, Scotland. First joint international conference on advances in mechanical and aerospace engineering will promise to promote and disseminate knowledge concerning several topics and technologies related to engineering and innovation. The main objective of ICAMAE 2023 is to bring together researchers, scientists, and experts in universities, companies, institutions, communities, agencies, associations, and societies to provide them with a unique platform for sharing and exchanging worldwide ideas, as well as the recent advances in mechanical and aerospace engineering. Esteemed guests and my dear fellow mates, we are absolutely honored to invite Mr. Satya Swarupanda, the chief guest, and dignitaries to kindle the flame of enlightenment and officially inaugurate our event by lighting the lamp.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रान्विता या वीणां वरदण्डमण्डितकरा या श्वेत पद्मासना या ब्रह्माच्युत शङ्कर स्तुतिभिर्देवैः सदा पूजिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा।
I kindly request Mr. Giri sir and the volunteers to felicitate the chief guest.
Moving forward, now I would like to take this time to introduce Dr. Reba Kora, Interim Dean, Alliance College of Engineering and Design, Alliance University. Dr. Reba Kora has over 28 years of experience in the field of engineering, academics, administration, and active research. She holds a PhD from Anna University, Chennai, and has about 70 research publications to her credit. She also serves as a doctoral level research supervisor in Anna University and Satyabama University, Chennai. She serves as a reviewer for the reputed Elsevier International Journal of Microelectronics and Emerald Compel International Journal for Computation and Mathematics in Electrical and Electronics Engineering. Dr. Kora is also the recipient of the Karnataka government's research funding to establish a Center of Excellence in Electronic Devices Modeling and VLSI chip design. I now kindly request Dr. Reba Kora to deliver the welcome address.
Good morning to all. Respected dignitaries on the dais, fellow faculties, deans, directors, researchers and participants, and all delegates and organizers from the University of Strathclyde who are attending online, and my dear students. Hearty welcome to the second Alliance Technology Conference and the first joint conference of Alliance University with University of Strathclyde, International Conference on Advances in Mechanical and Aerospace Engineering, ICAMAE 2023. In this era of technological advancements happening even in our lives, daily life, as an engineering community, we felt the urge to deliberate upon the advancements in the mechanical and aerospace engineering. Mechanical engineering is the first branch of engineering, and we always celebrate it as the king of engineering. Mechanical engineering has come a long way since the pulley and the windmill and so on. Today's mechanical engineers are developing self-assembling nanobots shaped like strands of DNA. They are revolutionizing transport from self-driving cars to magnetically propelled maglev trains and even vacuum-propelled hyperloops. There have been several recent advancements and inventions related to maintenance of equipment such as smart sensors, predictive maintenance, 3D printing, augmented reality, IoT, and the key trends include additive manufacturing, sustainable design, robotics, nanotechnology, biomechanics, energy harvesting, advanced materials, and human-machine collaborations, and the list goes on and on. Thanks to the advancements in electronics and artificial intelligence. So AI and ML being used to develop smart systems and automation in aerospace as well. Nowadays, we are dreaming of autonomous aircrafts and spacecrafts, or we are making it reality. These technologies help improve the safety and efficiency by enabling real-time monitoring of aircrafts and spacecrafts, predicting maintenance needs, and enhancing flight controls. The aerospace industry is transitioning to climate-conscious technologies to reduce carbon emissions. Advances in AI automate operations and enable autonomous flights, while small satellites cater to the low-cost operations. Smart materials and 3D printing will reduce production and performance bottlenecks. As we are about to deeply get engaged in such deliberations for the next 2 days, we are truly blessed to have with us Mr. Satyaswarup Panda, Director, Collins Aerospace, Bangalore, as the chief guest and the keynote speaker for today. I'm sure that he will enlighten us on cutting edge of connected battle space, autonomous systems, electrification of aircraft, cybersecurity, etc. As Collins in India is more into research and service to military and commercial aviation customers. On behalf of Alliance Fraternity and as the general chair of this conference, I extend a warm welcome to you, sir, to the inaugural session of ICAMAE 2023. I take this opportunity to welcome a very reputed person in Alliance University, Dr. Priestley Shan, Pro Vice Chancellor, Academic Affairs, a busy bee. In spite of his very busy schedule, he made it a point to be with us today. Thanks a lot for that. He is one of the strongest pillars, a pillar of support in all our endeavors. So on behalf of the conference organizing committee, I take the privilege to welcome you, Dr. Shan, to this August gathering. The speciality of this conference is the presence of our international partner, University of Strathclyde, Glasgow, Scotland. Dr. Thanasis and his team were diligently working with Alliance team from day one of its planning, and today, breaking the barriers of time and the climate, Team University of Strathclyde is here with us online to witness this inaugural event and to share their thoughts with all of us. On behalf of management, faculty, and students of Alliance University, I take this opportunity to extend a warm welcome to Dr. Thanasis and team, University of Strathclyde. This conference is going to witness 130 distinguished ideas in 5 tracks and so many sub-tracks for the next 2 days. I thank all the intellectuals who are physically present here, as well as those virtually present for their exemplary contribution, which helped us to bring out this conference in great shape. On behalf of Alliance University, I wholeheartedly welcome all of you to this conference. I also acknowledge the presence of our faculty colleagues, conference committee members, students, and student volunteers. Hearty welcome to all of you. Hope these 2 days will be a great learning experience for all of you. Before sign off, would like to congratulate and appreciate the organizing team for their meticulous planning and execution to make ICAMAE 2023 a grand event. Wish you all the best and thanks for your patient listening. Have a great day. Thank you.
Dr. Thanasis Tompis holds a PhD in Mechanical and Aerospace Engineering from the University of Strathclyde, Scotland. He is a lecturer and Strathclyde Chancellor's Fellow in the Department of Mechanical and Aerospace Engineering at the University of Strathclyde. Dr. Tompis has extensive experience in materials, welding and manufacturing research, specifically on the microstructural characterization and mechanical property assessment of processed metallic components. He has published many peer-reviewed articles in this field, including articles in materials and design, and presented his work in numerous international conferences and workshops. The research interests of Dr. Tompis are in the subject areas of advanced joining and surface engineering methods, and specifically laser welding, friction stir welding, and processing and friction surface of ferrous alloys. He has also supported many organizations in diverse failure investigations. I humbly welcome Dr. Tompis to give his address to the gathering.
I wonder if I can be heard.
Yes, we can hear you.
Can you hear me?
Yes, we can hear you.
So, dear colleagues, a very good morning and a very warm welcome to this first international conference on advances in mechanical and aerospace engineering. Now, I'm joining you this morning, unfortunately not from Bangalore, but from a very cold Glasgow in Scotland at the north of the United Kingdom. In fact, it's now just after 4:30 a.m. in Glasgow, and the temperature here is -1 degree Celsius. So in Strathclyde, we pride ourselves for developing research that is meaningful and impactful. And this is not just academic impact, but it's about industrial, financial, societal, environmental impact as well. When I visited the vibrant and beautiful Alliance University campus last November, I met people who are very kind, but also extremely welcoming. So welcoming, in fact, that I do remember fondly all of my days, or most of my days there. But I also found people who are quite ambitious and collaborative, keen to work together internally and externally in an open, respectful way, therefore reflecting particularly well the Strathclyde ethos and the way of doing things. I also met people who are innovative, aiming to generate impact and impactful activities and outcomes, irrespective of funding, equipment, resource availability, and so on. Again, this is finely tuned to Strathclyde's approach, where innovation is a crucial part of our values. And this is about remaining focused on discovering and applying knowledge with impact, and encouraging as well an environment which is creative and producing new ideas. In fact, this approach is so successful here in Glasgow that Strathclyde has had a key role and is still a major player of a considerable innovation entrepreneurship ecosystem across our city. As a result of all that I've been telling you, I can confirm that I'm really proud that this conference is a significant output of the collaboration between our two esteemed universities, Alliance and Strathclyde, which in fact share so much in common. I'm sure you will enjoy a very well organized and delivered, successful, impactful, insightful conference, where a wide range of the research conducted here in Strathclyde will also be presented. I wish you all the best. I'm looking forward to seeing you in the diverse sections and sessions in the next few days. And I want to extend a particular thanks to the organizing committee of the conference. Thank you and good morning.
Thank you, sir, for your address. Now, I would like to introduce Dr. B. Priestley Shan, Pro Vice Chancellor of Academic Affairs, Alliance University, to the gathering. Dr. Shan is a dynamic personality who actively seeks to empower the student body by making them actively participate in activities that seek to build their skills. Dr. Shan earned his PhD in biomedical engineering from Anna University, Chennai, and has published over 70 research papers. With several exceptional qualifications under his belt and a knack for spearheading many key initiatives and dedication to academic excellence, Dr. Shan plays a vital role in pushing forward Alliance University's vision of delivering world-class education and bringing a culture of research and innovation to the campus. Dr. Shan, I kindly invite you to come forward and address the gathering.
Thank you, dear. First of all, let me like to thank the guest of the day, who has come from Collins Aerospace, one of the most reputed companies in India. I'll come to why I'm calling it a reputed companies in India, which is helping India to achieve its dream of becoming the world's one of the biggest economic powers. Thank you so much for accepting our invitation, coming over here, sir. We are all eagerly waiting to hear from you. Let me thank and congratulate the Department of Mechanical Engineering, along with Alliance College of Engineering and Design, which is soon going to be transformed into Alliance School of Applied Engineering and bifurcated into Alliance School of Advanced Computing also very soon, maybe from the new year, which is going to come up. Let me congratulate the head of department, the conference secretary, conveners, and everyone for organizing the first international conference on advanced mechanical engineering, mechanical and aerospace engineering, along with Starlight Glasgow University. Thank you so much for our international partners also to coming forward. Let me also acknowledge the presence of our head of various departments, Director Publications and Dean Research was also here. Thanks everyone for joining your hands and bringing this particular conference to life. When India is marching towards with various schemes like Make in India, Atmanirbhar Bharat, Azadi Ka Amrit Mahotsav, which we celebrated recently, and Amrit Kal, which is going to come up very soon. I think I addressed the students earlier also in the same line. What we are going to do with the aerospace and mechanical engineering department is highly, highly, highly important. Yesterday, we at the university had a discussion regarding the new buildings which are going to come up. And what we made sure was we will try to ensure that the buildings that are coming up are sustainable buildings with net zero emissions. So what is the responsibility of an engineer when it is coming forward? I told that Collins is one of the most reputable companies in India, right? And when India is speaking about Atmanirbhar Bharat, or Indian government is giving a lot of push towards aerospace and defense industry, I strongly believe that the contributions of Collins has helped India to emerge as one of the highest exporters of aerospace components from India. So thanks to Collins for and the entire management team or leadership team of Collins for setting up an project over here. And coming to Karnataka government, I think Karnataka government was the first government in the state, in the country, to come up with a policy for a defense sector to push the defense manufacturing. And we had a lot of aerospace which are coming up from Karnataka. So we were sitting in a place which prominently works towards manufacturing of aircrafts and aerospace industry. Of course, the country is also widening. We have got a lot of projects that are coming up in the corridor between Chennai and Bangalore, the Krishnagiri corridor, which they call, and also there are a lot of projects coming up in Gujarat. So India as a whole is marching towards Atmanirbhar Bharat. I have got only one message to you guys before I wind up my speech. Last year we celebrated Azadi Ka Amrit Mahotsav, right? And we all were really proud, saying that India is into 75th year of India's independence, and we have achieved a lot. We are the top, one of the top 5 exporters of our manufacturer defense components in the world, actually. And we have started exporting our defense components also through our NAL, HAL, ISRO, and the success of ISRO recently. That's not the recent success, I'll say it's a success which has contributed to the last 30, 40 years of hard work from ISRO scientists, the Chandrayaan mission, the Mars mission, everything. It's helped us. Even when we lost, before 2 months, we hosted Padma Shri Mailsami Annadurai, who came here for addressing you guys. I don't know how many of you were part of that particular meeting. So it's a hard work that has come almost the way, and we are reaping a lot of successes. I always remember one cartoon which came before 10, 15 years. The Indian scientists were standing outside with a cow trying to enter in the elite club of NASA, and now we are inside that, right? So it's a proud moment for everyone when we talk about ISRO, NAL, and HAL, when we are exporting our defense capabilities to outside world. As students, what is your vision? Where are you going to place yourself? Maybe Azadi Ka Amrit Mahotsav was celebrated by the people who are on the other side of the dais, with your professors, with your scientists, with people like His Excellency Abdul Kalam. So all these scientists did a lot of wonderful job, and we reaped the benefits when we are celebrating the 75th year of India's independence. In 2047, when India is going to celebrate the 100 years of India's independence, where are we heading towards? What is going to be the contribution from you guys? That should be the outcome of the conference. I'm happy that 130 plus conference papers have been received in different areas of material, product design, etc. So whenever you are doing some project, keep something in your mind. We always focus on sustainable development goals, right? Soon our campus will become a campus which is free of plastics, which is free of all these materials which have been developed and which harms the planet, because we want to leave this planet as a better planet to leave to others. I myself has taken a very conscious decision that whenever I travel to the cities, if there is some electric vehicle available, I used to hire only the electric vehicles. In Bangalore also, we have this blue cars now in Delhi, and that's one of cheaper way. And second one is whenever we complete the travel, we get a report also, how much carbon emission you have reduced. But there are a lot of other discussions also, from where the electricity is getting produced. Electricity is getting produced from fossil fuels. And as engineering students, what is your contribution towards that as mechanical aerospace students or computer science students? Bangalore is becoming a hub for electric vehicle manufacturing also, autonomous vehicles. How are you going to contribute towards that industry? That will come only when you spend more and more time with your faculties. Spend more and more time with the labs that are coming up. You have a makerspace here, right? Professor Harinath is not. How many of you work with your makerspace? How many of the students are working with the makerspace? 1, 2, 3, 4, 5. Why can't I get more than 50% of students at least working with the makerspace? How many of you spend time after 4:30 with your professors? We have got a TBI. How many of you come up with the startup ideas? We had wonderful lectures. Good. We have wonderful lectures by the CEO of Natural just before 1 month. How many of you participated in that? Just open invitation given to everyone, right? How many of you participated? Opportunities will be given to you. It's up to you to take up the opportunities. So my message to you guys is, when we celebrate Azadi Ka Amrit Mahotsav, if India is in the top 5 economics right now, you should see it in the top 3, top 2 very soon. And that depends upon the hard work that you are going to put up, right? I'm happy that all the papers will be discussed over here. Students, please attend the conferences with full energy. If I'm standing before you and delivering this lecture, it's because of the first conference which I attended in 2007. That was in Ramachandra Medical College. I was basically I'm from electronics and communication engineering, but I attended my first conference over there. And there were people from GE, people from Philips who spoke about the ultrasound scanners, and they were talking about spectral noise detection systems. And they were talking about the difficulty in mitigating the spectral noise, the multiplicative noise. And that conference changed my life, I'll tell you. One conference which I attended in 2007, I registered for my PhD. In 2009, I was able to get my PhD. That's only because of one conference, the networking that I got, the people that I got connected. Then I came to Bangalore. I worked with the people over there. I got the data set and everything, and life was easier for me. The moment you are into some conferences, into some seminars, into some lectures, try to get the maximum out of it. Today morning also, we were having a meeting with Dr. Sheila was there. We were having a meeting today morning, and there was a proposal for an event actually. I was asking only one question. What is the outcome for the students? The outcomes will be materialized only if you are engaging yourself into the activities that we are doing. So for this conference, normally the conferences nowadays are just conducted for the namesake, which we don't advocate. Conferences are the platform which should be used for networking. We should be used for sharing your ideas, deliberating. I have seen conferences where the speaker will be speaking for 7 minutes, and 15 minutes, 20 minutes, there will be questions. Can you see some students who will be coming up with a lot of questions? We are talking about innovators, right? Alliance University is post for 4 things. One is for giving you placements in reputed companies. Second one is pushing yourself for startups or innovation. Or if you think that I want to become a leader in government organization, yes, you can take that path also. There are a lot of pathways actually. And the startups will come from the questions. All the startups have started from solving the problem which has been raised through some questions. So you will have to ensure that you're developing the habit of questioning a lot. So please engage into active discussions. Please engage into fruitful discussions. Sometimes this may be a life changer for all of you guys, even the faculties also. So to the session chairs, let us make these sessions as engaging as possible so that we'll be able to get more questions coming up at the end of the conferences, which you can take it as an problem statement for your projects also, right? So wish you all the very best. One last line of advice, maybe students will be bored of this advice from my side, but I like to reiterate again. Recently, just we completed a World Cup, right? How many of you watch cricket or follow cricket? We all were heartbroken on the last day, right? The same thing happened in 1996. 1996, when India was playing with Sri Lanka in 1996 in the semi-finals. I don't know how many of you know were following that World Cup match at that time. Sri Lanka, I was in 10th standard at that time. We were having small radios, so we had a PT period. We went to the ground. We hid behind a rock, and we were just hearing. First over, 1 wicket gone. Second over, 1 wicket gone. Srinath was bowling. Venkatesh Prasad took the catch in the third man. And when we came back, somehow their score was about 260-70 when we were looking at the TV. And by 7:38, Venkatapati Raju was crying a lot. But it's not that I don't want to push you towards the cricket fever at this point. At that time, one advertisement was very famous. The Hero Honda bikes advertisement. Put it, shut it, and forget it. Put the petrol, shut it, and because at that time only 2 bikes were very famous, maybe 3. Yamaha RX100 and the Suzuki and also some Bajaj. So Hero Honda came in the market saying that Yamaha is giving you 18-20 mileage. We'll be giving you 70 to 80 plus mileage. Put it, shut it, and forget it. So most of the events which we are attending are in that mode right now, right? Attend the event, leave the room, close the room, and forget what is happening in the room. The success of this conference will be measured only on the outcomes of this conference after 5 to 6 months. If some student can stand up and say that, if I am telling you that 2007, when I attended a conference in Ramachandra Medical College, and that transferred my PhD journey, that's because of the interaction that we had with the people over there. So interact as much as possible, deliberate with you guys, interact with the expert also who has come from outside. There are more than 40 papers which are going to be presented by faculties and researchers from outside our university. Interact with them, get their connect with LinkedIn, ask them the questions, ask them whether, if you are interested, ask them whether you can support me in my journey. That's where the success of this conference lies. Also, I am happy to note that the conference papers are coming up in the part of proceedings, and also they are going to be recommended for Scopus Index journals. Happy to note all these things. Alliance University has recently got a lot of laurels with it, right? We have entered into the QS ranking. How many of you know that we have entered in the QS ranking? QS is one of the world's prestigious ranking. And in Asia, there are 77,000 plus universities. And we are ranked in the 750 in the world, in Asia, actually. And in Southern Asia, we are ranked 239. So next year, we will be improving the ranking. The ranking will improve only when you guys contribute, actually. And coming to Amrit Kaal again, in 2047, if India has to stand tall among all the nations, you guys have to work really hard. You guys will have to come up with innovation. You will have guys will have to publish some patents. We'll give you all the support. We want to celebrate Amrit Kaal in 2047 along with you guys, and we want to see you guys leading India's mission. When the last one point, when recently one success was done, this Chandra, I'll take the example of Chandrayaan only. Chandrayaan was head by Veera Muthuvel, right? One scientist, Veera Muthuvel. He is not a graduate from IIT. He is not a graduate from NIT. He is not a graduate from the top 10 or top 50 top 100 universities of this country. He was a graduate from Sai Ram Engineering College in Chennai. How many of you know that college? 1, 2, 3, 4, and maybe when he studied, it was in third tier college, I'll tell you. And now he's heading India's leading mission. So we want you guys to see that when we are sitting in the homes and looking at 2047, the Amrit Kaal, we want you guys to lead this India's prestigious missions. We want to see you successful. God bless you guys, and take part in all the discussions very actively. Ensure that you are also developing some good projects. Your exams are coming up. All the best for your exams. And also, I'd like to wish you a happy new year. Maybe this is the last time we are meeting up. We'll meet you in January with a lot of full energy. Come up with a lot of good positivity next year after your exams. Together, let us achieve something which makes India proud. Thank you, and God bless you all.
Moving on, now I take the opportunity to call the dignitaries to release conference proceedings. Proceeding further, Dr. Mohit Hemant Kumar sir completed his PhD from Department of Mechanical Engineering, National Institute of Technology, Trichy. He has done postdoctoral research from King Mongkut's University of Technology, North Bangkok, Thailand. He is a life member of Institution of Engineers, Powder Metallurgy Association of India, Society of Failure Analysis and Science. Dr. Mohit has published many articles in high-quality international peer-reviewed journals, book chapters, and presented research papers at national and international conferences. I welcome the convener, Dr. Mohit sir, to address the gathering.
Okay, good morning to one and all present here. So good morning, distinguished guests, Honorable Pro Chancellor, Mr. Abhijit Chebbi sir, Pro Vice Chancellor, Dr. Prisley Shan sir, Chief Guest, Mr. Satya Swarup Panda sir, Director Aerospace College, then Dean ACD, Dr. Rima Gora ma'am, Organization Chair, Dr. Girish BM, sir, Professor and Head, Mechanical Engineering Department, ACED, Dr. Athanasios Tompis from University of Strathclyde, and esteemed colleagues, participants, and my dear students. I am delighted to welcome the first joint international conference on advances in mechanical and aerospace engineering, ICAMAE 2023, which is jointly organized with the University of Strathclyde, Glasgow, and currently we are hosted here at Alliance University, Bangalore, India. So myself, Dr. Mohit Hemant Kumar, as a convener and one of the lead organizers of this prestigious conference, I express my sincere gratitude for your presence at this moment, even on behalf of the entire organizing committee. The field of mechanical and aerospace engineering has undergone remarkable growth and innovation in recent decades. As researchers and professionals, we are responsible for continually pushing boundaries, thinking creatively, and developing solutions that wield a meaningful impact on society. The significance of this conference lies in its capacity to bring together leading experts from the worldwide, especially from Austria, Thailand, Germany, Netherlands, then UK. Then we have from participants from Nigeria and many other countries included. Facilitating discussions on recent advances, emerging trends, and cutting-edge technologies, which is available in this engineering field. So over the next 2 days, this conference will promise an enriching experience by featuring a keynote speaker from our chief guest and one more from University of South Australia, and 5 different tracks, especially from material science, production, design, flow and thermal, and aerospace engineering. So each track covers diverse topics by providing a comprehensive overview of the latest developments in this upcoming emerging and dynamic fields. So I encourage you all to actively participate and seize the opportunity to network with our peers, exchange ideas freely, and make the most of the intellectual platform. So let the conversation and collaboration sparked at this conference serve as catalyst for groundbreaking research and technological breakthroughs. Before I conclude, I would like to express my heartfelt thanks to Alliance University and the University of Strathclyde for their unwavering support and invaluable partnership on organizing this conference. Additionally, I appreciate all the dedicated reviewers, committee members, advisory boards from different countries whose contribution have played a pivotal role in making this event a grand success. As we embark on the next 2 days in insightful discussions, I wish each one of you an intellectually stimulating, fruitful, and memorable conference experience. Thank you for being a part of this exciting journey. Thank you so much, Paul.
Thank you, sir. It now gives me immense honor in introducing today's chief guest, Mr. Satyaswarup Panda, Director, Collins Aerospace, Bengaluru. He is an engineering leader with over 25 years of experience in aviation and energy industry. He has taken up significant roles in his career, serving important organizations such as General Electric and Collins Aerospace, with roles in increasing responsibility. During these years, he has had diverse experience leading cross-functional teams in product and technology, development, and aftermarkets, quality, localization, and cost out, etc. In his current role as Director for Engineering at Collins Aerospace, he leads multiple COEs, such as program management, technical publications, test labs, and multiple shared functions supporting across the enterprise. He holds an MSc in Engineering from the Indian Institute of Science, Bangalore, and an MBA in Finance from BITS, Pilani. He has been recognized with several management awards for leadership, innovation, program management, customer issue resolutions, and production. Now, I would kindly request our chief guest, Mr. Satyaswarup Panda, to address the gathering.
Again. Good morning. Not happening. That's better. Let's try it once again. Good morning. Thank you. That's like Alliance University, right? Okay, so I'm Satyaswarup Panda. I'm one of the directors engineering in Collins Aerospace. Before I begin, I would like to thank the faculty members, organizing committee, especially Associate Professor Sasmita, for really kindly inviting me. It's a pleasure to be here. Wonderful campus, bright sunny day, and a conference to look forward to, right? So really happy to be here. Before I begin, I just wanted to have a show of hands. How many from mechanical here? Not so many. Aerospace? Okay, so how many from other departments? Nice. Okay, good. No, the reason that I asked is so that I can maneuver accordingly, and I'll fashion my talk accordingly. Good to have multidisciplinary here, because the world today is the engineering today is a lot of interplay of technologies, right? There is now today, in today's world, you cannot be working in silos saying that I will only do this, I will only do this, right? So of course, every department has to come together, but there is a openness required in terms of working together. So everything has a multidisciplinary system approach today, right? So that's why I just thought, let me check first. Okay. So yeah, so I have a very I'll maybe around 50 minutes or so, I'll be talking next predominantly on a couple of areas. One is I will talk a little bit about Collins Aerospace. What do we do? I think that will be also, I know that the conference is about advances in mechanical and aerospace engineering, but I think this will be a lot of interest to see where the industry is going, in terms of aerospace, where it is headed, what are the key priorities, and what Collins does will of course be of interest to you. And then I'll slightly pivot and talk about advances, especially in mechanical and aerospace. This is not be all end all. I'm sure your papers would be much more deep dive into, but I'll try to cover an overview of different things that is happening. And then, if we have time, then we'll take a few question answers. Okay. Okay, we'll start with Collins Aerospace. So how many of you have heard about Collins Aerospace? Okay, not bad. How many of you have heard about RTX? Couple of them, good. Okay, how many of you have heard about Boeing? Okay, how many of you have heard about Airbus? Yeah. I wanted to let you know that RTX, we are part of RTX. Collins Aerospace together with Pratt & Whitney. Pratt & Whitney is our sister concern. And Raytheon. Raytheon is not so much in India because they are into entirely missiles and defense. So being a strategic technology, there is very little amount of work that happens out of India. But Collins and Pratt is predominantly present in India. And RTX is the #1 company in aerospace and defense in the world, as per Forbes. Okay. So 180,000 employees worldwide, 67.1 billion, more than 10% of it goes into research and development activities. Okay. Now I'll talk about Collins Aerospace. So 73,000 plus employees, out of which 16,000 plus employees are only into engineering. And in India, we have almost like 3,000, 3,500, or more than 20% of entire engineering workforce is there in India. Okay. We do have production also. We have 1,400 people supporting production. We have 300 million plus exports that happens out of India. So Collins Aerospace production started almost around 25 years back. Okay. So we have been doing Atmanirbhar Bharat even before it was launched by Prime Minister Modi. Okay. So strong, we have a commercial team, engineering team is present both in, Bangalore and Hyderabad, and total around close to 5,500 employees serving Collins Aerospace in different areas out of India. 23 billion with more than again 10% going into research and development activities. Mix of commercial and military. Some work of military happens, mostly all the commercial activities happen out of India. We are, it's a good combination of 60-40 of, OEM and aftermarket. Okay. We have a legacy of innovation. Arthur Collins started. So these are all different companies which came together under the umbrella of Collins Aerospace. Arthur Collins started the Collins radio. Okay. David Sunstrand started the electric system, all your generators and for the flight, and environmental control system, all your ACs and all that was started by Hamilton. So Hamilton and Sunstrand came together as a company called Hamilton Sunstrand. Benjamin Goodrich, which started with a tire making company, and India also we started by the name of Goodrich Aerospace Systems. Fred Rover started the nacelle system, and Ratier started the propeller system. So all this come together to make what is Collins Aerospace today. Okay, so we have a legacy of innovation and just continues. Okay, so now let me ask to whoever said they know Collins Aerospace, they have heard about what does Collins Aerospace do? Just trying to make it interactive. Right? Any idea? No? Okay, so how many of you have traveled in flight? Okay, at least you would have seen it, right? So as soon as you get through the bridge, you enter the plane, right? What do you see? What do you see? What do you see on the left? The cockpit. We do that cockpit. The entire solution is done by Collins. On the right hand side, what do you see? Seats. What else? Do you see the lights? What else? You go to the fag end, you see the galleys where you have your chillers, food service, food, beverages and all stored. That's called the galleys. You have the partitions, right? You have the lavatories, right? All that is done by Collins. Okay. Whatever you don't see, who controls your flight surfaces? Actuators, right? We do that. We do the landing systems, the wheels and brakes. We have the sensors, which you don't see usually, right? The cargo deck, where all your stuff goes in, right? Okay. And things that you don't want to see, right? Oxygen system, right? Evacuation slides, you don't want to see them, right? I wish nobody sees them at all, ever. But we still do that. Okay. So everything that you see inside the flight, barring the, tube, the main body, and the engines. Engine, again, our sister concern, Pratt and Whitney does. Okay. Everything else Collins does. So we are the tier 1 supplier for all aerospace companies in the world. Okay. So this kind of summarizes, everything that we do. I talked about cockpit. I talked about, evacuation slide, landing gear, emergency power, cabin, crew seats, sensors, radar, exterior lighting, interior lighting, power distribution system, lavatory, everything, fuel system. Okay. So I hope this kind of emphasizes what and helps you understand what Collins does. Okay. Now, what do? We power it. We power it and start it. All the primary, secondary generation, APUs and all that, right? So we power it and we start it. We ventilate it. All the environmental control system is done by Collins. We control it with all our actuators and, primary and secondary flight surfaces. We control it. We monitor it with all our sensors and navigation system. We monitor it. We protect it. Okay. We land it and we stop it using our landing systems and wheels and brakes. Okay. So we do pretty much everything that you can see inside the aircraft. Okay. So talk about some of the strategic initiatives. I just have this slide to let you know what is the technology for future, right? What is the technology for future? Anyone? What do you hear? Take a shot. Go ahead. Autonomous flights. What else? Okay, we'll start with autonomous flight. What is flight autonomy? Right? We have scarcity of flight pilots. Okay. Pilots is also, even if we have, pilots are under tremendous stress because a lot of decision making on the fly. Right? So we enable them. Okay, we provide them with intelligence. How do we do that? We have advanced sensors that captures the information, what altitude it is flying, what is the fuel level, right? How is the weather outside, right? So imagine if you are, forget about flying, if you're driving, right? Yeah, you have a foggy weather, you have limited visibility, right? How do you drive? Sometimes Bangalore rain also, it is difficult to drive, right? How do you do that? In Europe, at least in your vehicle while you are driving, you can park on the side and you can say, okay, let me wait till it subsides, right? But in flight, you cannot say that let me wait somewhere and park it, right? So when the vision is, very blurred or difficult to see, we provide with synthetic vision. Okay. So we embed the intelligence that we have in terms of and enhance the vision for the pilot. Even if there is very foggy weather, stormy weather, whatever, pilot can still see through. We create that vision so that pilot can land it. Isn't it amazing? So we have, so what enables it? Like you have advanced sensors, you capture the information, you build intelligence on top of it, right? So all technologies that we talk about. So today you may be, hearing a lot of buzzwords in terms of all digital, AI, ML, this, that, and all, right? So everything comes into play in this kind of situation. Okay. So next is connected battle space, although very less work happens here in India, but I'll just still take the privilege to, at least for your, knowledge, connected battle space. Today, we have technologies where you don't have to go into another territory to launch an attack. For reconnaissance or surveillance, right? You send a swarm of drones that goes, they are connected and they're talking to each other. They do the surveillance, give you the intelligence. You can launch attack also, right? So all that, connected battle space is what we do. We have cabin experience. So inside cabin, I think one thing that COVID did well was to really spearhead the innovation, right? Now, everybody all of a sudden started talking about antiviral coatings, anti-bacterial coatings, UV sanitization and all that, right? So this all comes into, so a lot of safety features that got built in. On top of that, let's say, how cool is it when you travel next time and the in-flight entertainment remembers, what kind of, do you watch movies, do you watch sports, what documentary do you watch and all that, and plays it for you, right? It is all stored in your phone. You can hook up and, give a home kind of feel experience. It also knows, what is the mood lighting that you like, what shades you like, right? What are your food preferences? So a lot of customization, comfort, right? All your ergonomics, all that comes into touchless, one, like I said, COVID, one thing that again it has done is bring in a lot of touchless technology. So make the whole, even in your lavatory or elsewhere, bring in a lot of touchless technology that makes the cabin space more safer and comfortable for the passenger. So that is called the cabin experience. Connected ecosystem. I think nowadays everywhere, even our vehicles are connected, right? So what it means for aerospace is, first thing, inside the flight. Inside the flight, you have all systems and subsystems talking to each other. You are gathering the information and doing prognostic self-monitoring more actively, right? How it helps? It reduces your unscheduled maintenance activities, improves your flight dispatchabilities, right? So number one, it brings all the system and subsystem of the flight together. Number two is also connects to the ground, right? Continuous communication is happening. Customer, today you have so many apps where you can directly see the flight positioning in the entire globe, not just your city or India or entire globe, which flight is going where and everything you can see, right? So customers also know what is their flight status live. So the entire, customers, airliners, ground staff, aircraft, everybody is talking to each other. Electrified aircraft. So, so many, we still have a lot of hydraulics and pneumatic systems in the aircraft. The idea is, but you cannot just, if it was so simple, you cannot just go in with an electrified aircraft. I mean, you cannot just substitute them, right? Reliability, losses, so many other things are there. So that is also a work in progress. Electrified aircraft, hybrid aircraft, complete battery technology, right? You would have heard about so many. So, but what you would have heard about is some UAVs flying with a completely electric aircraft, right? But imagine Boeing 737 or 777 going with a complete battery technology. It requires enormous amount of, power. Integrated solution. So integrated solution is a system approach where, we are talking of bringing multiple functionalities into the same thing. Now, no more sensor does only sensors or structures does only structures. Now we want to have structures which can house the antenna, which can house the sensor, it can house the actuation system. It does more functions than one. So how it helps? Reduce the space, reduce the weight, right? And thereby contributing to, flight efficiency, fuel efficiency. Structural technologies. You would be hearing a lot about, carbon-carbon composites. You would be hearing about thermoplastics. Thermoplastics are nowadays gaining attention, a lot of attention because of their recyclability, right? So as the world is driving towards sustainable technologies, thermoplastics is gaining a lot of attention, not just recyclability, but also, I think producibility is easier and so on and so forth. There are a lot of advantages with thermoplastics. Also carbon-carbon composite. Just to, give you an example, if an aircraft goes and has a failed landing, you understand failed landing? Just goes, could not take up and has to brake again, right? The amount of energy that goes in just stopping the aircraft is equal to what 6,000 kg lithium ion battery can hold. Okay, I hope it gives you an appreciation of how much energy goes in just stopping the aircraft. Now, we are talking of battery technology, which is cool. Now imagine just for one failed braking, if it takes 6,000 kg of lithium ion battery, imagine to fly the aircraft, how much you need, right? So structural technology becomes very important. Till we get there, technologies like carbon-carbon composite, which can actually are very lighter and help to in this kind of containing the energy kind of applications, I think they go a long way. So there is a lot of attention, and of course, like additive and so on and so forth. There are other technologies also. So these are 7 different pillars of technology that Collins is focused on. I'm sure you would be hearing a lot about, let's say, hydrogen as an alternate fuel, and like complete electric aircraft and all that. But I'll tell you this: some of these technologies that we are talking about, it will be work for next 10 to 15 years. All these technologies that I'm talking about. Hydrogen is still far ahead. Okay, aerospace is a slow adopter of technologies. We have all technologies in the house. Whatever cool technologies that you talk, our engineers work on them. But working on those and putting them in the flight are 2 different things. Imagine something flying at 30,000 feet level. You can't take chances. Like I said, you can park your vehicle by the side and say that, okay, let me make the decision, call somebody. You cannot do that while. So, safety is of paramount importance, or very, very critical aspect. That's why these technologies have to really mature. We are talking about, let's say, technologies like additive, right? I can tell you there are hardly anything. There are today, additively manufactured parts which are in the aircraft, but it is non-safety critical. Okay. If you want to introduce those technologies for safety critical equipments, a lot of maturation, a lot of testing, a lot of data generation, and reliability has to be really proven before something can be put in aircraft. Okay. So that is where, these technologies, will require next 10 to 15 years of maturation. Like, let's say, for example, autonomous operation. Today, we have the technology where, you can, or aircraft can fly without a pilot, right? Just like the autonomous vehicle that is running, right? But the question is, would you want to, travel in a flight where the pilot says, I'm working from home today? No, right? We're not yet there. So, although we have some of these technologies, and I'm sure you know that it goes through tremendous amount of regulations, right? Anything that we put in the aircraft, you would have heard about FAA, EASA, and all those regulatory bodies, right? The amount of it's very stringent. The amount of regulation that comes in is very stringent. So some of these technologies, we feel like, yeah, we are there, but there is a difference between, yes, we have the technology versus can we, put it in the aircraft. Regulations also have to come along with the, technologies development. So some of these technologies will be working through next 10 to 15 years, so these are some of the technologies for the future. Okay, so with that, I hope I am able to give an appreciation about aerospace as an industry, what Collins does, and what are the path forward for the aerospace industries. There's a lot more, but I would like to pivot and, with the theme of, or the conference theme, of advances in mechanical and aerospace, I'll share my experiences from an industry standpoint. Okay. Yeah, so I put together a brief agenda. I'll talk about advances in simulation, digital twin, system engineering, material and manufacturing processes and factory of the future. Again, this is not, lot of work is happening. If you just pick one thread out of, let's say, simulation or digital twins, I think there's a lot of research going on. This is a very bird's eye view of what are different things that are happening. Again, not a comprehensive list, but based on my experiences I just put together, but we can chat more if you have any things specific later. So before I begin, I wanted to quote that fundamentals remains the same. Okay, today, mechanical, let's say, mechanical and aerospace, engineers feel like battery technology has come, right? So amount of moving parts and excitement of designing the piston and the cylinder and all that is gone. Solar is coming. So now you have other technologies coming in. So the excitement of being mechanical and aerospace, I see that people are not so very sure about where are we going. Do we have enough? It is not looking exciting, right? But I want to tell all of you that the design philosophies are changing for sure. Let's say when I studied, we hardly care about sustainability, right? That was not a consideration. But now when you do something, you got to also worry about how is it being produced, how much carbon footprint it has in the production, right? So the design criteria is changing. The design challenges are changing. Let's say, it's not enough to just have something solar. You got to also figure out, or even for battery technology, right? You got to also figure out how are you doing to manage the thermals, right? You see the cool looking designs now, very fluidic. So the importance of your aerodynamics and, fluid dynamics is coming to the core. It's not so much when I started off. So, the design philosophy is definitely changing, but pushing the boundaries. Okay, but what remains same is your fundamental. So you still got to read all this, right? You got to still do the, machine design, fundamental, strength of material, fluid dynamics, heat transfer, calculus, all that still remains relevant. If you think that you can use AI to bring up a design, my friend, you have to still validate that it works, right? AI will help, but you got to make those decisions. Okay, today technology has enabled engineers to perform better, right? But imagine if you are an engineer who is building a part, you got to make decision whether it is working fine. AI is nothing but it will pick some 1,000 stuff and give you some amalgamation of all that, right? But you got to still make that decision, evaluate it, productionize it, all that, see aftermarket aspects, all that, right? Before to put something. So the fundamentals remains the same. So, good news for people who, love all this, subjects. Bad news for people who thought AI I can use and do something. You got to still read those subjects to make decisions. Okay. Okay, so I'll talk about advances in simulation first. Okay. How many of you remember AutoCAD or know AutoCAD? Have you heard of AutoCAD? Oh, pretty cool. Have you used a drafter ever? Okay. Yeah, this was the time when I started off my career. We used to have 2D AutoCAD. I mean, we're just transitioning from a drafting based, thing to learning about AutoCAD, doing 2D and 3D, right? So in CAD. So this is how it started off. Okay, slowly and slowly. And we used to back then work on, even for simulation, we used to work on 128 MB, machines. Okay, I'm talking about ROM, not RAM. Okay, so every element, every node that we create used to be very critical. Okay, we'll have to show 40 elements, 50 elements kind of analysis we used to do. But now with the advent of computing power, this is where we have transitioned. Let's say now the entire gas turbine, entire flight, along with all the details, you can do it in CAD and C, right? So this is how the advancement in CAD has happened. Now, what has happened when I started off again, this is you can look at it as, a thermal analysis or stress analysis predominantly, or even thermals, because you can see the temperature around the engine and all that. So this was the basic analysis when I started off my career. We were doing just the basic analysis, although it shows a flight, but I mean aircraft, but it could be anything, right? The computational fluid dynamics today, when again, I think we have come so far in terms of using machines, high power machines to do some kind of, because this can run into days and months. Sometimes you fire a run and it's going on forever, right? So a lot of complex, aerodynamic simulation. This is image of a submarine and the acoustic analysis being done. The fan blade out, you would have heard about fan blade out or sort of crash analysis, where there are a lot of explicit simulation. Okay, some sort of impact, very small time. So this is a shape optimization, of a, or you can call it a topology optimization of a seat. Now today, the technology like additive makes this a reality. When we were studying, or in the early stage of maybe 15, 20 years back, this used to be more like a cool looking thing, but nobody knew how to produce it. Now you have technology where you can just optimize it and go and print it, right? This is a mold flow analysis. You could pretty much simulate today mold flow or rubber flow and those kind of simulations, and understand how to reduce those hot spots and where to place your chillers and those kind of thing. This is a wind turbine blade analysis, classic example of a fluid structure interaction. You have heavy wind blowing, you have the structural load both interacting with each other, right? This is a Viper simulation, more automobile or flight, we do this. It's a lot of complexity. So you have this fluid and structure talking to each other, but at the same time, you have this elastomer undergoing a lot of nonlinear changes, right? So the slushing behavior along with material nonlinearity. So, very high complex simulation again. This is a nozzle spraying. So where you have the phase change with all this multi-physics simulation, like, or tools like COMSOL and all that coming. Even now, I think ANSYS also has it. So a lot of phase changes also you can model, right? And this is sort of flow path optimization sort of analysis, and even it has got biomedical application in terms of how the stent design and all that can be also done, but also heat exchangers, right? A lot of heat exchangers, how optimally you can build the heat exchangers is, so this kind of technologies enable that as well. So basically, I think the computational power today that you have, literally less than what your mobile has. We used to run simulation back then. Your mobile is much more powerful than where we started off. But I think we have come a long way in terms of really mimicking the real world. I used to work for GE prior to Collins, and we used to have this icing and fan blade out sort of analysis. Today, I can tell you that we are at a, it takes years to mature it. A lot of data, feedback loop, and really refining the model and the predictions better, right? Till you get there. You cannot just like that eliminate the test, right? But I can tell you, we still do the test, but enormous amount of savings because of the computational power and how you can mimic the real world in your computer, right? So this is what technology enables us. Again, I'll take it a little further, talk about digital twin. What do you understand by digital twin? Anyone? Okay. Okay, then I have to rush. I have quite a few slides. Okay, digital twin is where you are mimicking the physical system in your computer. It can be a simple stress analysis model. It can be the whole aircraft as well, right? It depends on what is the size that you want to deal with. So this is what we call today physical meeting digital, right? And it can be, so I have put a lot of examples like the vehicle or the gas turbine or the wind turbine, but literally it can be as small as, you can do at a system level, you can do at a subsystem level, you can do at a component level. Okay, again, switch gears a little bit, talk about system engineering. This is something gaining attention a lot these days because everybody wants to really mimic the entire system, right? So in a software world, what it means is that you start with a system, subsystem design, component design, do that all assemble together, integrate, verify, and then validate. But in a practical, for hardware, what it means is that, let's say, you have your vehicle, you have your steering system, transmission system, fuel system, braking system, suspension system, so on and so forth, right? You take any system or even your seats. Okay. So seats now you model as blocks, right? And build in those parameters. What is the material? Where is the bushing? What is the, where is the crankshaft and all that, right? So you bring all that together and try to predict how let's say how in a crash situation, how does it behave, right? So basically, and then, once you have built in the fidelity into it, then start tweaking it to really, improve the design much further. So now today, your technology enables you to, do everything, in your computer before actually going out and implementing in the design. So that's a system approach. In system, again, multiple disciplines coming together and, working to develop it. Advances in manufacturing, I talked about thermoplastic. Like I said, more than recyclability is of prime consideration. But other than that, I think the producibility aspects and, it is lighter. But now we are talking, have you heard of boom? Boom Aerospace. So we're trying to build supersonic flight. Earlier it was there, but there were some challenges. But when you are going for supersonic, I think temperatures becomes a big deal. How do you handle temperature? Thermoplastics are not known to, withstand high temperatures. So, but there's a lot of attention going into thermoplastics. Again, hydrophobic material, nanoscience, graphene kind of material. There is a lot of attention on this in terms of, the coatings that you come up with, and ceramics, because if you want to increase efficiency, if you want to achieve higher output, then you have to go for higher temperature, and only ceramics can enable that. Additive manufacturing, example of a bracket, medical application, combustor case. The advantage of additive manufacturing is that, sir was saying, fill it, shut it, forget it kind of thing. Before you realize you have it printed. But now the challenge is it still needs to develop it, right? You cannot really, when mass production, you cannot use it, right? How do you do the post-processing, the surface finish, right? Number of materials available is less. You cannot print with whatever material that you want. And again, like I said, regulations, passing it through regulations and before putting it on the flight. Again, so these are some of the aspects that needs to be worked on to develop additive technology. Again, the support structure, building the support structure is one key area in additive manufacturing. A lot of attention now is going, how can you predict something that is performance or something that is printed, right? So that is also an active area of research. Industrial revolution, we talked about how we started off industry 1.0 with steam power and then moved to electrical power and then use of robots or what we call as cobots. But now it's all about IoT, sensing, feedback loop, all that, right? So use of AR, VR, mixed realities and in your tab or your phone, you can pretty much see the entire thing. Okay. So this is how the industry 4.0 looks like. You have all technologies there, right? Now, what it means for, I want to take a pause here. I want to say what it means for a mechanical or a aerospace engineer. It's all looking like it's all for computer science and right? More digital, fully digital. But let me tell you, I mean, today we are in a world where you're still, like I said, your fundamentals remain the same, right? The producibility, the inspection technology, these technologies only enable you. So you got to have an appreciation, let's say, for data analytics. You need to be able to understand. So these are something, today, mechanical or aerospace you have to have an appreciation for this, where you can read the data, understand and interpret. This is how the performance should be. This is what it is. Is it talking to each other? And make decisions based on that. How AI/ML, like I was talking about, AI/ML, you don't have to code it yourself or you don't have to learn the large language model or whatever, but you have to know that how to use it to come up and with optimal designs, right? Again, optimal design, not additive. Again, mass production, right? So you got to make decision in terms of mass production. So some of these technologies, I think we got to, like I was telling, like today there is a lot of interplay of technology. So your mechanical or aerospace, you got to stay with fundamentals. But again, appreciation for some of these technologies will help you become a better engineer. Okay, and last but the least, I think I've just put some examples of where the industry trend is. I put some examples of from aerospace, moving from aerospace industry, but really it is applicable to any industry. Even if you talk about appliances, your appliances in home also now started talking to each other. Your fan and lights are talking to each other, right? So optimize the energy. So sustainability or, electrification, autonomy, and cleaner and greener and quieter future. I think that's what everybody is. That's why I said design criteria is changing today. So the envelopes are being pushed further for, more efficiency and reducing the carbon footprint and all that. But, and this is not typical of aerospace. This is typical of all the industries today. Okay. So with that, I think I'll end my talk, and I mean, I don't know if we have time for question and answer, but I can hang around if you want to have a chat. But thank you for once again for inviting me, and pleasure talking to all of you. I wish a very enriching conference to for everybody who is involved. Whether it is speakers, students, or the faculty members, everybody. So with that, I'll sign off. Have a good day. Thank you.
We appreciate your professionalism and want to thank you for your time. Moving further, Dr. Girish BM is a professor and head of mechanical engineering. He is specialized in material science and engineering and manufacturing processes. He has a PhD in mechanical engineering from the Mysore University, and his research areas include wear corrosion and mechanical properties, evolution of metal matrix composites, and advanced metallic alloys. He has several research papers to his credit in reputed international publications of Elsewhere, ASM, ICAMAE, EWIS Journal on Wear, Corrosion Science, etc. He has been recognized by Elsewhere Publications, Amsterdam, for his outstanding contribution in reviewing. He has reviewed close to 50 research papers. He is also a recipient of prestigious award for research publications given by Vision Group of Science and Technology, Information Technology and Biotechnology, Government of Karnataka. I humbly welcome him for the address and further to the vote of thanks.
The timing of the conference on advances in mechanical and aerospace engineering couldn't have been more apt than what it is today. Though the horizon of mechanical and aerospace looks a bit dull, clouded by IT, it is not going to stay for long. Okay, the clouds have to make way for the sun to shine. So the days when mechanical engineering and aerospace will shine are not far off. Maybe in another 2-3 years, when we host a much bigger international conference, things would be better probably. Okay, why I say this? Because the world, and especially the Indian space, is making way for manufacturing of aerospace components, defense-related components in a big way, as you are all aware. Big companies, big business houses, such as the Tatas, the Reliance, the Mahindra, the Godrej, the Adanis, along with lesser known people who are into manufacturing of aerospace components like the Wipro, and even most surprising name which has emerged in this space is Raymond. Okay, so more and more of business houses are venturing into manufacturing. Why they are venturing? Because they see a potential there, and with players like Collins Aerospace already being present. So this space is going to grow. There is no other option for this. This is going to grow. In the time to come, there will be a huge amount of growth. And when you all come out of your engineering career, when you move out of the portals of this university, if you have the right skills, then there are the opportunities available. So develop the right skills and be ready and proclaim to the world that you have arrived. Okay. I thank the leadership team, the young and charismatic Honorable Pro-Chancellor in absentia, Sri Abhayji Chabi. He was very happy to learn about the details of the conference when we explained to him about the number of papers and the countries they represent, the authors represent. We had representation from more than 24 countries. Okay. He was very happy, he was very excited and wanted to be part of this event, but his pre-engagements would not allow him to do so. So anyway, I thank him in absentia. I thank Dr. Prishli Shan, Pro Vice Chancellor, Academic Affairs, for his presence. He was here for a short time. In fact, he is traveling today, because of which he couldn't be here for long. I thank him. I thank the chief guest of today's function, Dr. Satyaswarup Panda, Director Collins Aerospace, for his time and for the valuable keynote address which he has delivered. He will be here for another some time. The students, faculty of both the departments can interact with him. Okay. I thank Ms. Surekha Shetty, Registrar General, Alliance University in absentia. I thank Dr. Reba Kora, Interim Dean, SEED, for her presence and support throughout the various stages of this conference. I thank the deans of various schools, directors of various schools, the heads of various departments, faculty colleagues of ACED, especially from mechanical and aerospace departments, the conveners of the conference, Dr. Sasmita and Mohit, for their continued efforts and for making this day happen. Thanks to the students, the student volunteers, the branding team, the purchase team, the IT team for their support. Thank you very much.
I request Girish sir to felicitate the chief guest once again. Now it's the time for tea break. I would like to request our guests and the fellow mates to treat yourselves. We will resume the parallel sessions at 11:15 p.m. Can everyone please stay back for a group photo?